दोस्तों हमारे YouTube चैनल बी ब्लॉग में आपसे स्वागत है। आज पढ़ने जा रहे हैं हम कुछ इंपॉर्टेंट क्वेश्चन। केमिकल काइनेटिक्स फ्रॉम द कंसंट्रेशन ऑफ C4H9Cl butyl chloride at different time given below. Calculate the average rate of reaction C4H9Cl plus H2O to form C4H9OH plus HCl during different interval of time T0 C6H5Cl mole liter inverse 0.10 50 0.905 100 0.820 150 0.0741 200 0.0671 300 0.0549 400 0.0439 700 0.0210 and 800 0.017. We can determine the difference in concentration over different interval of time and thus determine the average rate by dividing delta R by delta T. Second question, the decomposition of N2O5 in CCl4 at 318 Kelvin has been studied by monitoring the concentration of N2O5 in the solution. Initially, the concentration of N2O5 is 2.33 mole liter inverse, and after 184 minutes, it is reduced to 2.08 mole liter inverse. The reaction takes place according to the question. 2 N2O5 gas for NO2 gas plus O2 gas. Calculate the average rate of this reaction in terms of hour, minutes, and seconds. What is the rate of production of NO2 during the period? Solution average rate equal to 1 by 2 minus decrease in concentration reactants N2O5 upon O delta T equal to minus 1 by 2 2.08 minus 2.33 mole liter inverse upon 184 minute 6.79 into 10 power minus 4 mole liter inverse minute is equal to 6.79 into 10 power minus 4 mole liter inverse minute into 60 minute upon 1 hour equal to 4.07 into 10 power minus 2 mole liter inverse upon H equal to 6.79 into 10 power minus 4 mole liter inverse into 1 minute upon 60 seconds equal to 1.13 into 10 power minus 5 mole liter inverse second. It may be remembered that the rate is equal to 1 by 4 delta NO2 upon delta T. Delta NO2 upon delta T is equal to 6.79 into 10 power minus 4 into 4 mole liter inverse minute inverse equal to 2.72 into 10 power minus 3 mole liter inverse minute inverse. For the reaction R tends to be the concentration of reactant change from 0.03 molarity to 0.02 mole in 25 minutes. Calculate the average rate of reaction using units of both time both in minutes and a second. In a reaction to a final product, the concentration of decreases from 0.5 mole liter inverse to 0.4 mole liter inverse in 10 minutes. Calculate the rate during the interval. 4.3. Calculate the overall order of reaction which has the rate expression A. Rate equal to K1 A power 1 by 2 B power 3 by 2 rate B. Rate is equal to K A power 3 by 2 B power minus 1. Rate equal to K AX power A power X B power Y order X plus Y. So order 3.2 plus 1 by 2 equal to 2 second order 2 plus minus 1 equal to 1 by 2 half order. Identify the reaction order from each of the following rate constant. K is equal to 2.3 to 10 power minus 5 liter mole inverse second. K is equal to 3 to 10 power minus 4 second inverse. The unit of rate second order reaction is liter mole inverse second inverse. Therefore K is equal to 2.3 minus 4 liter mole inverse second inverse represents a second order reaction. The unit of first order reaction constant is second inverse. Therefore K is equal to 3 into 10 power minus 4 represents a first order reaction. The initial concentration of N2O5 in the following first order reaction N2O5 gas NO2 plus half O2O was to 1.24 into 10 power minus 2 mole liter inverse at 318 Kelvin. The concentration of N2O5 after 60 minutes was 0.20 into 10 power minus 2 mole liter inverse. Calculate the rate constant of the reaction at 318 Kelvin. For a first order reaction, log R1 upon R2 equal to KT2 minus T1 upon 2.303. K is equal to 2.303 at T2 minus T1 log R1 upon R2. 2.303 60 minutes minus 0 log 1.24 into 10 power minus 2 mole liter inverse upon 0.2 minus 2 mole liter inverse 2.300 upon 60 log 6.2 minute inverse K is equal to 0.0304 minute inverse. The following data were obtained during the first order thermal decomposition of N2O5 gas at constant pressure. 2N2O5 gas 2N2O4 plus O2. First second time 0.5 pressure ATM 0.512. Calculate the rate constant Let the pressure of N2O5 decrease by 2x atom as 2 moles of N2O5 decompose to give 2 moles of N2O5 gas and 1 mole of O2 gas. The pressure of N2O4 gas increases by 2x atm and that of O2 increases by x atm to N2O5 to N2O4 plus O2 at start 3 equal to 0.5 atm 0 atm 0 atm time t 0.5 minus 2x atm 2x atm x atm Pi equal to Pn2O5 plus Pn2O4 plus PO2 0.5 minus 2x plus 2x plus x is equal to 0.5 plus x is equal to Pi minus 0.5 Pn2O5 is equal to 0.5 minus 2x equal to 0.5 minus 2 Pt minus 0.05 0.5 in 1 equal to 1.5 minus 2 Pt at t is equal to 100 second Pt is equal to 0.512 atm. Pn2O5 equal to 1.5 minus 2 into 1 0.512 equal to 0.476 atm using equation 4.16 k equal to 2.303 upon t log p1 pi upon p equal to 2.303 100 second log 0.5 atm upon 0.476 atm equal to 0.303 into upon 100 second into 0.0216 equal to 4.98 into 10 power minus 4 second. A first order reaction is found to have a rate constant equal to 5.5 into 10 14 seconds and find the half-life of the reaction. Half-life for a first order reaction is T half equal to 0.693 upon K. T half equal to 0.693 upon 5.5 into 10 power minus 14 second and equal to 1.26 in 14. So that in the first order reaction time required for completion of 99.9% is 10 times of the reaction. When reaction is completed 99.9% Rn is equal to R0 0.999 R naught. K is equal to 2.303 log R0 upon R equal to 2.303 T log R naught upon R naught minus 0.999 R naught equal to 2.303 T upon log 10 cube. T is equal to 6.909 upon K for half life of the reaction T half is equal to 0.693 Kelvin T upon T half is equal to 6.909 upon K into K upon 0.693 is equal to 10. Hydrolysis of methyl acetate in aqueous solution has been streamed by titrating the liberating acetic acid against sodium hydroxide in the concentration of ester at different times is given below. So that it follows pseudo first order reaction as the concentration of water remains nearly constant 55 mole liter during the course of reaction. What is the value of K dash in this equation? Rate equal to K CH3 COO CH3 H2. For pseudo reaction, the reaction should be first order with respect to ester when H2O is constant. The rate constant K for pseudo order is K equal to 2.303 upon T log C naught upon C where K equal to K dash H2. It can seem that K dash H2 is constant and equal to 2.004 into 10 minus 3 meter inverse, and since it is pseudo first order, we can now determine K from K dash H2 is equal to 2.004 into 10 power minus 3 meter inverse. K 55 mole liter inverse equal to 2.004 into 10 power minus 3 meter inverse. K dash equal to 3.64 into 10 power minus 5 mole liter inverse. Terminate if first order reaction has a rate constant 1.15 into 10 power minus 3 second inverse. How long will 5 gram of this reactant take to reduce to 3 gram? Time required to decompose SO2 Cl2 to the half its initial amount is 60 minutes. If the decomposition is first order, then calculate the rate constant of the reaction. The rate constants of a reaction at 500 Kelvin and 700 Kelvin and 0.02 second inverse and 0.07 second inverse respectively. Calculate the value of EA and A log K2 upon K1 equal to EA upon 2.303 R T2 minus T1 upon T1 T2 log 0.07 upon 0.02 equal to EA upon 2.303 to 8.314 kilocalorie Kelvin inverse mole inverse into 700 minus 500 upon 700 into 500 0.544 equal to EA into 5.714 into 10 power minus 4 upon 19.15 EA is equal to 0.544 into 19.1 and 5.714 into 10 power minus 2 1823 0.8 joule. K is equal to A power minus E upon RT 0.02 is equal to A power minus 18 through 30.8 upon 8.314 into 500. A is equal to 0.02 upon 0.012 is equal to 1.61. first order rate constant for decomposition of ethyl iodide by the reaction C2H5 T2H4 plus HI at 600 Kelvin in 1.60 into 10 power minus 5 second inverse. Its energy of activation is 209 kilojoule. Calculate the rate constant of the reaction at 700 Kelvin. Log K2 minus log K1 equal to EA upon 2.303 R 1 upon 1 minus T2 minus 1 minus T upon T1. K2 equal to K1 plus EA upon 2.303 R 1 upon T1 minus 1 upon T2 log 1.60 10 power minus 5 plus 9,000 joule mole inverse upon 2.303 into 8.314 mole liter inverse K inverse 1 upon 600 Kelvin minus 1 upon 700 Kelvin log K2 equal to minus 4.796 plus 2.599 equal to minus 2.197 K2 equal to 6.36 into 10 power minus 3 second inverse. The activation energy for the reaction 2HIS2 plus I is 2.9.10 kilojoule mole inverse at 581 Kelvin. Calculate the fraction of molecules of reactant having energy equal to or greater than the activation energy. For a reaction 2A plus B, A to be the rate constant K, A B square equal to with K equal to 2.0 to the power minus 6 mole inverse liter square second inverse. Calculate the initial rate of reaction when A is equal to 0.1 mole liter inverse, B is equal to 0.2 mole liter inverse. Calculate the rate of reaction after A is reduced to 0.6 mole liter inverse. The decomposition of NH3 on platinum surface is 0 order reaction. What is in the rates of production of N2 and H2 if K is equal to 2.5 into 10 power minus 4 minus n mole inverse liter second inverse. 4.1 in a pseudo first order hydrolysis of ester in water the following results were obtained. T 0 30 60 90 ester upon mole liter 0.55 0.31 0.17 0.8. First calculate the average rate of reaction between the time interval 30 to 60 seconds. Calculate the pseudo first order rate constant for the hydrolysis of ester. In a reaction between A and B, the initial rate of reaction R naught was measured for different initial concentrations of A and B as given below. A, B, R naught 0.20, 0.30, 5.07, 0.20, 0.10, 5.07, 0.40, 0.05, 1.43 into 10 power minus 4. What is the order of reaction with respect to A and B? The following results have been obtained during the kinetic studies of the reaction 2A plus B, C into plus D. Experiment A mole upon liter inverse B of mole upon liter inverse initial rate of formation of D liter inverse minute first second third 4 0.1 0.3 0.3 0.4 0.1 0.2 0.4 0.1 6.0 into 10 power minus 3 7.2 into 10 power minus 2 2.8 into 10 power minus 1 24.40 into 10 power minus 2. Determine the rate law and the rate constant for the reaction. The reaction between A and B is first order with respect to A and 0 order respect to fill in the blanks in the following table. Experiment A mole liter inverse, B mole liter inverse, initial rate mole liter inverse minute. First second third 4 0.1 dash 0.4 dash 0.1 0.2 0.4 0.2 2.0 to 10 power minus 2 4.0 to 10 power minus 2 2.0 to 10 power minus 2. The experiment calculate the half life of a first order reaction from the rate constant given below 200 second inverse 2 meter inverse 4 years inverse. The half life for radioactive decay of 14 carbon is 57 30 years. An archaeological artifact containing wood has only 80% of the 14 carbon found in a living to estimate the age of sample. The experimental data for decomposition of N2O5 O5 equal to 4 N2 plus O2 in gas phase at 318 Kelvin are given below. T0 400 800 1200 1600 2000 2400 2800 3200 in power 2 into N2O5 mole liter in 1.636 1.36 1.14 0.93 0.78 0.64 5 0.53 0.43 0.35. Plot N2O5 against T. Find the half-life period for the reaction diagram between log 2O5 and T. What is the rate law? Calculate the rate constant. Calculate the half-life period from K and compare with A. The rate constant for first order reaction is 60 second inverse. How much will it take to reduce the initial concentration of the reactant to its 1/16th value during nuclear fusion? Explosion of the product is 90 SR with half-life of 28.1 years. If 1 mg of 9 if microgram of strontium was observed in the bones of newly born baby instead of calcium, how much of it will remain after 10 years and 60 years if it is not lost metabolically? For a first order reaction, so the time required for 99 completion is twice the time required for the completion of 90%. A reaction, my first order reaction takes 40 minutes for 30% decomposition. Calculate here for the decomposition of isopropane to hydrogen and nitrogen at 534 43 Kelvin. The following data are obtained: T P mm of H 0 360 720 35 54 64. Calculate the rate constant. The following data were obtained during the first order thermal decomposition of SO2 Cl2 at constant value. SO2 Cl2 gas, SO2 plus Cl2 experiment time, second number, total pressure 120 100 0.5 0.6. Calculate the rate of reaction, total pressure 0.6580. The rate constant for the decomposition of N2O5 at various temperatures is given: T degree Celsius 0, 20, 40, 60, 80 T in power minus 3 kilosecond and 0.078 1.70 25.7178 2 A140 diagram between ln A and 1 by T, and calculate the value of E and A predicts the rate constant at 30 degree and 50 degrees Celsius. The rate constant for decomposition of hydrocarbons is 2.4 into 10 power 5 second inverse at 546. If the energy of activation is 179.9 kilojoule per mole, what will be the value of pre-exponential factor? Consider a certain reaction A to product with K equal to 2.0 to power minus 2 second. Calculate the concentration of A remaining after 100 seconds. If the initial concentration of A is 1.0 mole liter in 1. Suppose decomposes in acid solution into glucose and fructose according to first law with T half equal to 3.00 hours. What fraction of sample of sucrose remains after 8 hours? The decomposition of hydrocarbon follows the K equal to 4.5 Newton per minus 1 second inverse e power 230 kT. Calculate E. The rate constant for first order decomposition of H2O2 is given by the following equation: log K is equal to 14.34 minus 1.25 into 10 power 4 K upon T. Calculate E for the reaction and what temperature will the half period will be 256 minutes. The decomposition of N2 product has value of K 4.5 into 10 power 3 second inverse at 10 degrees Celsius and energy of activation 16 kilojoule mole inverse. At what temperature would K be 1.5 into 10 power minus 2 second inverse? The time required for 10% completion of a first order reaction at 298 is equal to the that required for its 25 completion at 308 Kelvin. If the value of A is 4 into 10 power 10 second inverse, calculate K at 3118 Kelvin and E. The rate of reaction quadruples when the temperature changes from 393 to 330 Kelvin. Calculate the energy of activation of the reaction assuming that it does not change with temperature. दोस्तों इस इतने सवाल को आप लोग लगाइएगा, चैनल को लाइक सब्सक्राइब शेयर करना मत भूलिएगा। धन्यवाद दोस्तों। ये क्वेश्चन कुछ जो हमने बताया आपको, ये क्वेश्चन होमवर्क के लिए है। धन्यवाद।